Now, one of the things we could also do is we could, for example, calculate the Spearman correlation between our SPY and our factor. So we could do this here. We could go Spearman R. And then we go factor.SPY and reds.SPY. And again, that gives us nans because it's probably got some in there. So let's just see if we can do it with a drop in A. We can probably get rid of them. Or actually better is if we do a fill NA 0, because then, you know, if we do a drop NA, we never know exactly. We know they have the same length, but if there's a few NAs in the other one and a few different ones in the other, then the length will not match and we won't get anything. So we just fill them with zeros. And there you go. See, actually, this is interesting. The Spearman correlation is actually significantly higher than the normal correlation. So that tells us this factor is actually quite strong. So let's just try this for gold as well. In this case, because we have GC equals F, we can't just use simply the dot. And look at this, 0.11. That's actually really high. Like this is really pretty good. Well, let's just try the other ones as well. Maybe we find something interesting there. Wow, 0.13. So what this tells us is we did a linear correlation and it didn't turn out to be very good. However, obviously, these correlations that we see in there, they are not really linear because we see that the Spearman R actually gives us quite strong signal. And so, as I said before, normally when we do a Spearman rank correlation and we find factors larger than 0.025, they can be interesting. So something that is as high as 0.13 is actually really, really significant and it's quite useful. So what was the final instrument that we had in here? DLT as well. just out of interest. So we've got quite a lot of predictive value in these. Oh, and it's 0.1. So all of them seem to have a good correlation and also a good p-value. Now, that's really a great result. And so effectively what that tells us is, well, our factor has some value for research. Now, the problem is because we don't really know exactly what the relationship is between our factors and the moving average divergence, we still have to do a bit of work to figure that out. But at least we can see that there is definitely some interesting results here, and it's worth exploring that further as a trading strategy and see what we can make of it. So that's effectively how you would go about in finding predictable factors. We can always say, oh, well, you know, if we have a certain movement in our factor, that should really correlate to a specific movement, or statistically at least correlate to specific movement in our returns. That's what's really important here. What we can then do is, and we've done this, or we looked at this before, we can then combine different factors with each other. And so if they're not very correlated with each other, we can actually produce a very stable and well-returning trading strategy from this. One more thing I wanted to do is, so we've got our factors, right? We call that factor. And we've got all these. And I think what I would like to do is just finding the correlations between those factors. And so what I'll do is I'll just drop the nans here. There's a lot of them. That shouldn't be the case. So we expect a 4x4 matrix. So what we need to do, we need to transpose it. There you go. So this is basically our correlation matrix here. And you can see there's some of the correlations are quite high here, 39%. And then here, this is quite interesting. This is quite strongly anti-correlated. So I think that would be TLT and SPY. They're usually quite anti-correlated. Oh, no, it's not. So this is the second one and the fourth one. So that would be gasoline and TLT. They're quite strongly anti-correlated. Interesting, isn't it? So, there's obviously some correlation there, but it's not too bad. So if we build a trading strategy, so they would probably add up to a nice portfolio later on, which can then be weighted and optimized a bit to make it better.